So let's continue reviewing limits. So look at our first example in this video. Let's find the limit as x goes to 1 over x minus 1 squared. So again, we try our first thing that we always do is just try to plug in the number. If I plug in 1, I get 1 over 0. Now this tells me that my answer is either going to be infinity or negative infinity, but we have to look at the sign. So here we're going to look at the left-hand limit. And the right-hand limit. So let's start with the left. I need to know, is this going to be positive or negative? So plug in a number just a little bit smaller than 1, just a little bit to the left of 1. So if I plug in like 0.5, well, because the bottom is squared, it's going to be a positive over a positive. So overall, I'm getting a positive here, which means this left-hand limit is going to be infinity. Now, if I look at the right-hand limit, again, plug in a number a little bit bigger now than 1, maybe 1.5. Again, you're going to have a positive over a positive, which means overall it's positive. So this limit would also be infinity. Now you want to compare your left-hand limit and your right-hand limit and see, are these the same? They are indeed the same, so I can then conclude that the limit as x goes to 1 does exist and it's equal to infinity. So there's my answer. So you need to make sure that these here are the same. Well, since we looked at one-sided limits, let's do some more examples with one-sided limits. So find each limit, the limit as x goes to 1 from the left. So again, you plug in your number here. So if I plug in 1, I get 1 minus 3 over 1 minus 1, negative 2 over 0. So again, because I'm getting a 0 in the denominator, but I'm not getting a 0 in the numerator, I feel like my answer should be infinity or negative infinity. And the question is, you've got to figure out the sign. So here, if I'm approaching 1 from the left, that means a little bit smaller than 1. So plug in 1/2. So in the top, if I plug in 1/2 squared minus 3 times 1/2 over 1/2 minus 1. So I'm getting 1/4 minus 3/2 over a negative 1/2. So in the numerator, I'm getting a negative. 3/2 is bigger than 1/4. In the denominator, I'm getting negative. So overall, I have a positive. So this limit will be positive infinity. 1 from the left, it was x squared minus 3x. It's going to be a positive infinity. So now let's look at instead the right-hand limit of the same function. So we don't have to plug in 1 here because we already did that previously and got a 0 in the denominator. So infinity or negative infinity. And the question is, which one is it? Well, you're going to have to plug in again a test number. Now you're doing a right-hand limit, so you want something a little bit bigger than 1. So maybe plug in 1.5 or 3/2. So over here, I'm getting 9/4. I'm getting 9/2. And 1/2. So in the top, you're going to get a negative, and the bottom, you get a positive. So overall, my answer is negative. So this limit, this right-hand limit, is going to be negative infinity. So let's look at a couple more limits. So let's look at some that involve infinity. So find the limit as x goes to infinity, 2x squared minus 3x plus 8 over 4x squared minus x. So remember, when you're doing these limits at infinity, if you have a rational function, which is a polynomial over polynomial, you can compare degrees. So here, if I look for my largest degree in the top, it's 2. It's in x squared here. And my largest degree in the bottom is 2 as well. So if they have the same degree, which they do here, then the limit becomes the ratio of these coefficients here. So this limit would be 2 over 4, or 1/2. Let's look at another one of these. So find the limit. The limit as x goes to negative infinity, x squared plus x over x cubed plus 5. So here, again, I have a rational function, a polynomial over polynomial. Look at your largest degree. So in the top, the degree is 2. In the bottom, the degree is 3. The bottom has larger degree. So when the bottom has larger degree, the limit is going to be 0. All right, let's look at one more. Let's look at the limit. Find the limit. The limit as x goes to infinity, x to the 4th plus x over x squared plus 1. So again, we look at, it's a rational function. Look at the largest degree in the top, it's 4, in the bottom it's 2. So the numerator has larger degree, which means your answer is either going to be infinity or negative infinity. So you're going to have to pay attention to x is going to infinity, so x is positive. If x is positive, the numerator will be positive, the denominator will be positive. So overall, it's a positive. So in the end, the limit as x goes to infinity of this function will be infinity.